Fusion welding joins two pieces of metal by fusing the edges, forming one solid piece. Welding rod usually is added to build up the joint. The rod used is of similar composition to the workpiece. This produces welds with the same melting temperatures and of the same color as the base metal, with corresponding high tensile strength. Cast iron, wrought iron, carbon steel, alloy steel, copper, brass, aluminum, nickel, and lead can be joined by oxyacetylene fusion welding. Let's sit in on a lesson in fusion welding to see how a good weld is made. In this lesson, we will weld steel. First, we must learn the feel of the blowpipe. To do this, we will melt a strip across a piece of sheet steel while adding rod metal. Control of the molten puddle and penetration of welding heat are very important in fusion welding. Use a neutral flame for fusion welding. Start with an excess acetylene flame. Then reduce the amount of acetylene until the feather has just disappeared. Hold the inner cone of the flame about 1/8 inch away from the surface of the sheet until a pool of molten metal about the size of a 10-cent piece has formed. Move the flame and the welding rod in semicircular motion to control the puddle size and also move it across the sheet. Add welding rod metal to the molten puddle to build up the weld bead slightly higher than the surface. Hold the blowpipe at a 45-degree angle to the surface of the sheet. Move the puddle forward about 1/16 inch for each side motion. Notice that this strip is uniformly wide and has regular, evenly spaced ripples. Now let's use this technique to weld two 1/8 inch sheets together. These sheets have been beveled at the edges to assure deep penetration of weld metal. Space the sheets about 1/16 inch at the right, widening to about 1/8 inch at the left. They will be drawn together as the weld proceeds. Tack weld the sheets in position by directing the flame equally over the edges of both sheets. As the sheets melt, add welding rod to form a small weld. You will need to add more rod metal to tack weld this side because of the greater spacing between sheets. To start the weld, reheat the tack weld at the right until the forward edge and the adjacent edges of the steel sheets are molten. Before the molten puddle is allowed to flow ahead, the edges of the metal should be melting to permit fusion with the weld puddle. To ensure a strong weld, you must melt base metal to the bottom of the joint. Then add enough rod metal to build up the joint slightly above the surface of the sheet. Use the same blowpipe and rod motion learned in the last exercise to move the puddle across the sheets and melt both edges evenly. If the molten puddle is moved too rapidly, the weld bead will be too narrow. If the puddle is moved too slowly, the bead will be too wide and may even burn through the sheets. Hold the blowpipe at an angle of 45 degrees to the workpiece to allow preheating of the joint, even rod deposit, and control and movement of the weld puddle in a continuous operation. Keep the puddle size constant at about the size of a dime. For each side motion of the flame, the puddle should advance about 1/16 inch. Remelt the second tack weld into the advancing puddle. Notice that this weld has the same appearance as the practice bead. Now we are ready to weld heavier metal. Here is a side view sketch of plates to be fusion welded in two passes. Tack welds at 12 to 15 inch intervals hold the plates in position for welding. Since we are working with small plates, a tack weld at either end will maintain spacing. Lay the first pass for the full length of the seam. Be sure to melt the sides and bottom of the V so there will be complete blending of rod metal and base metal. The second pass fills up the V and is built up slightly higher than the surface of the plates. This weld cross-section shows the complete blending of weld metal with base metal to form one solid piece. Let's try it. These plates have been beveled at the edges to form a 90-degree V. Because of the plate thickness, we will leave a 1/16 inch gap at the right side, widening to about 3/16 inch at the left. We will also use a larger blowpipe tip and a larger size of welding rod because we are welding heavier metal. The greater thickness of the metal also will require more rod metal to make a good tack weld. As the area under the flame starts to melt, add rod metal to fill the gap and form a puddle. Greater spacing between plates at the left side can be filled gradually by depositing rod metal to form a large puddle that will bridge the gap. For welding heavier plates such as this, hold the blowpipe at an angle of 60 degrees to the plate. Now reheat the first tack weld just as you did before and add rod metal to form a puddle. Since this is much heavier plate, we will make the weld in two passes. This first pass builds a layer of fused base and rod metal half filling the V. Follow the same welding procedure that you used in welding steel sheet. Deposit rod metal until the puddle is slightly larger than 1/2 inch in diameter. Remember to heat both sides of the V evenly. Use the welding rod and the flame to move the puddle along the V. Notice how the sides of the V become molten ahead of the advancing weld puddle. By directing the flame more on the rod than on the puddle, you can prevent the puddle from becoming too fluid and difficult to control. Proper control of the weld puddle comes with practice. Control puddle movement with the flame and the welding rod. Remember, the puddle will flow naturally in the direction that has been heated. Weld penetration is always important in fusion welding. Make sure that the sides and bottom of the V are melted before moving the puddle forward so that weld metal combines with base metal to form one continuous piece. Finish this pass just as you finish the weld in thinner metal. Melt the tack weld into the advancing puddle. Now we lay the second pass just as we did the first. Heat penetration and puddle control are just as important in this second pass as in the first. Both the sides of the V and the top of the first pass must be molten as you make the second pass in order to fuse completely with deposited rod metal. If the puddle grows too large, draw the flame away and let the puddle harden slightly before trying to move it further along. Remember that the weld bead will be the same width as the weld puddle. Keep the weld bead even in width while you are building it up. As the weld puddle approaches the left edge of the plates, direct the flame to melt down the edge. As soon as the edge begins to melt, play the flame back to remelt the weld puddle. Continue adding rod metal and move the puddle forward. Build up the weld so that it has the same evenly rippled surface slightly higher than the plate surface that we made in sheet steel. The finished weld will be of the same width and height as the weld we made in thinner metal. Let's review the important points we have covered. Always space plates to be welded. 1/16 inch at the right, wider at the left, depending on plate thickness. Use a larger size blowpipe tip when welding heavier thicknesses, and also use a larger size welding rod. Adjust the blowpipe flame to neutral. On the first pass, melt down the sides of the V. Add welding rod metal after the sides and bottom are molten to form the weld puddle. Keep the puddle moving. On the second pass, melt the sides of the V and the top of the first pass so that there is complete fusion between the two passes. Build up the weld slightly above the plate surface. Practice making fusion welds in all thicknesses of metal. Learn to control the molten puddle and build up welds that are uniform in appearance. You can learn to make top quality welds at high speeds with oxyacetylene fusion welding.